So, without further ado, I'm going to start this event. So everyone knows this event is being recorded and will be available afterwards. I'm not going to pronounce the title of the event in English, but I'm going to switch a little bit. I'm going to switch over to Icelandic now for a brief time and walk people through the agenda. Já, góðan daginn allir og takk fyrir að mæta á þennan viðburð hjá Opnum Kerfum. Í samstarfi við RedHat OpenShift og Nýsköpun án takmarkanna með RedHat OpenShift og Opnum Kerfum. Dagskráin sem hér segir. Við erum núna að bjóða ykkur velkomin og svo fyrsti fyrirlestur mun ég taka og í framhaldinu kemur Hakan Hagenrud sem lausnasmiður hjá RedHat og fer í gegnum að sýna okkur aðeins inn í plattforminn. Svo tökum við 5 mínútur í smá coffee break þannig að þið getur sótt kaffi eða te eða hvað það og eftir það tekur Rasheed Amir við sem hjá Stakater sem RedHat Premier partner eins og við og að gera svipaða hluti og segir frá sínum plattform í hvað þeir að gera í Svíþjóð og svo kemur Eero Arvonen frá Enento og talar aðeins Future Finance Data Innovation with Open Banking. Svo verðum við með smá spurningar og lokun á viðburðunum eftir það. Og við múum sjá hvernig tíminn. Það þá bara undirbúa núna að svissa yfir á næsta glærusett. For the English speaking audience, the first presentation will be in Icelandic, so if you want to learn some Icelandic, perhaps you can pick up a few words there, but the rest of the presentations are in English. Jæja, þá ekkert úr vegi en að bara byrja. Fyrsti fyrirlesturinn sem ég mun kynna heitir Hitchhiker Guide to OpenShift sem verður þá svona stutt yfirferð á hvað OpenShift og af hverju OpenShift og svo framvegis og í framhaldinu taka Hakan og fleiri við með smá demos þar sem sjá aðeins meira inn í plattformin og þá byrjum við bara. Fyrst aðeins háleitar hugmyndir. Stundum þarf háleitar hugmyndir til þess að búa til nýsköpun og við þekkjum þetta náttúrulega með fullt af vörum sem hafa verið búna til sem hafa breytt markaði og sem dæmi bara, við tökum bara Uber og Airbnb og svona lausnir sem hafa breytt hlutum og þetta vissulega nýsköpun og oft svona brjálæðar hugmyndir verða að einhverju sem gjörbreytir því sem við gerum í framtíðinni. Og nýsköpun í viðskiptum allt í kringum okkur og það náttúrulega þannig að bara hvaða fyrirtæki sem og hvað gera geta unnið að nýsköpun og skapa sér sérstöðu og þannig skila ávinning til viðskiptavinna sína. Og þetta náttúrulega það sem allir að leita að og má sjá, var eitthvað skilaboð Já. Einhverju sem ekki að heyra í mér bara svona áður en ég fer lengra? Ef ég skrifið inn í tjattið áður en að ég fer lengra. Ok, það verið að heyra í mér, þannig að þá held ég áfram. Og í tengslu við þetta, þá hjálpar það að nýta sér tækni á sviði opins hugbúnaðar ásamt því að tilenga sér opin kultúr í því hvernig verið að skila lausnum. Og einfaldlega bara því að við erum að sjá að allt þetta svona opna samfélag er að hraða framþróun. Og en við þurfum að geta skilað lausnum til viðskiptavin okkar, sama í hvaða formi það og þá snýst þetta alltaf það að reyna að koma hlutum hratt áfram á markaðinn og til viðskiptavina eða þeirra sem eiga neyta þjónustunar og það alltaf orðið meiri krafa að hanna lausnirnar þannig að þær séu cloud friendly, forrit sem eru fædd í skýinu. Og svo bara eins og við sjáum bara trendið að það alltaf að koma meira og meira það að þurfa að geta verið með gervigreind eða velrænt nám eða greiningar. Gögn orðin nýja olían og að leita að einhverjum fjársjóði í gögnunum gulls í gildi. Og internet hlutana náttúrulega að koma meira og meira inn með alls konar mælum eða þess hlutum sem þarf að sækja út og vinna með. Og svo í rauninni aftur að nýsköpunarkúltúrin mjög mikilvægur í þessu samhengi bara að ná að koma upp þessari snerpu og hraða í því að skila lausnum út. Og það oft að breyta kannski svona vinnumódelinu í kringum hvernig við gerum hlutina. Og við viljum meina að gámar eða containers og Kubernetes og fjölskýjalausnir lykilþættir í svona vegferð. Og OpenShift eina bestu lausnunum til að skila lausnum sem byggja á gámum eða örþjónustu svona based plattformum og við ætlum að kafa aðeins ofan í það. Með OpenShift þá getur þú afhent öll forritið þín með nýjum hætti og það möguleikar í plattforminum að geta tekið inn til dæmis hefðbundin forrit sem hafa verið að keyra á síndavélum og keyra hreinlega síndavélina inn í OpenShift plattforminum og samhliða því getur þú nota þá svona Kubernetes nálgun á því að skila út þessum forritum þínum sem þú varst áður með í síndavél sem fór í gegnum eldveggi og alls konar æfingar. Þú getur unni með það þá svona á Kubernetes Kubernetes aðferðafræði eða já. Og samhliða því í rauninni getur unnið að því að smíða forrit sem fædd fyrir skýið og jafnvel farið alla leið upp í það að vinna með gervigreindina og vélræna námið og farið yfir í serverless með functions. Og þannig að þú ert komið með heilstæðan svona container gáma plattform og DevOps umhverfi sem þú getur hýst á brúninni. Þú getur hýstað í gagnaveri, þú getur hýstað í hybrid eða blönduðu skýi eða fjölskýi, multi-cloud. Og af hverju viðskiptavinir að velja RedHat OpenShift? Það einfaldlega því að þetta traustverður Kubernetes og þú ert að fá sömu upplifun hvað sem ef þú þarft að færa það á milli skýja. Og þú ert að fá hugbúnaðar katalóg og fleira sem hjálpar þér við að efla forritara til nýsköpunar. Og allt byggir þetta á Opnum hugbúnaði sem líka í boði sem opin hugbúnaðir í software katalógnum. Þannig að þú getur endurnýtt mikið af þeim lausnum sem plattformin byggir á í þínar eigin lausnir. En það vissulega áskoranir í því að fara í svona container-based plattforma og það ýmislegt sem þarf að huga að. Og það meðal annars öryggin á gámónum þínum eða konteinerunum að þú þarft að passa upp á að uppfæra images hjá þér sem að þú ert búin að bilda ef það kom upp veikleikar og ekki láta hann hanga óplástraðan af því að þú bildaðir image fyrir ári síðan. Þú ert alltaf að uppfæra stýrikerfispakkan og allt sem undir konteinerinu þínum til þess að tryggja mögulega samhæfni við ISO-vottanir og annað, þannig að til dæmis það kemur að úttekt að þú ert að sýna fram á að þú hafi verið að plástra umhverfið þín og þau séu að þessu hugsaðu öryggið. Og svo eru áskorunir í svona dag 2 umsýslunni, eftir að búið að setja kerfið upp að það þarf kannski að stækka clusterinn, hvernig ætlar að gera það, hvernig á að framkvæma uppfærslur og ýmsar uppsetningar og hvernig ætlar að samþætta við núverandi umhverfi og tækni, önnur kerfi sem eru og svo það náttúrulega dreifing forritana eða bara svona delivery módelið, hvernig á það að vera útfært, hvernig á að mæla það og svona almenn umsýsla í kringu það, sem og að geta veitt notandanum möguleika á að nota þau tól og tæki sem hann vill nota, sem eru vinsæla á markaði hverju sinni. Og svar RedHat við þessu í rauninni RedHat OpenShift, sem þá þeirra Kubernetes plattform, þar sem að þeir eru þá að tryggja stöðugt öryggiseftirlit á plattforminum sem slíkum og passa upp á að það berist til þín öryggisuppfærslur hratt og vel og eru með gott þjónustunet til þess að hjálpa okkur sem viðskiptavinum að vinna með lausnina og hvort sem að þjónustumódeli hjá þeim háttað þannig að þó að þú kannski hugsi fyrst og fremst að senda á það þegar þið vantar hjálp þegar eitthvað bilað, þá getur líka sendt beiðnir á það þegar þú ert að setja eitthvað upp og eitthvað ekki að virka sem skildi. Þannig að það nú mikilvægt að hafa það í huga líka að þegar það verða að reyna að koma eitthvað upp í production og ert ekki komin alla leið. Þú ert náttúrulega með skýja upplifun hvar sem það alltaf konsistent umhverfi og þú ert með sjálfvirka umsýslu, þvert á stakkinn, þannig að þú getur í rauninni alltaf operatað umhverfið eins sama hvar þú ert með það hýst. Og þú ert að gefa forriturunum breytt úrval af tækni og straumlínulegum ferlum við að gera hluti, þannig að þú áttu auðvelt með að forriturinn á auðvelt með að sinna sínu verkefnum dálítið sjálfur, sem að á þess að þurfa að fara mikið undir hútið. Það að setja upp Kubernetes og gera það rétt getur verið erfitt verk, allavega fyrir þá sem er ekki búin að kafa mikið ofan í tækninu og ekki búin að vera lengi í þessu svona ekosystemi og það margir hluti sem þarf að huga að og ég búin að setja út nokkra punkta hvað það varðar og þetta vissulega, þetta ekki ómögulegt verk en þetta tekur tíma og getur þá eitt kannski í rauninni upphaflega takmarkinu að fara hreinlega í það að skapa lausnir, að þú sett farin að vinna undir húddið, þannig að maður það stoltið að passa sig að það fín lína þarna á milli og 75% af notendum í fyrirtækjum hafa verið að segja að þetta sé svona stærsta flækjustið við að taka upp svona plattform og þannig að það svona kannski svona eina af þessum stóra áskorunum að það kannski ekkert tiltökumál að setja upp plain vanilla Kubernetes en svo þarf það að bæta við fullta íhlutum ofan á til þess að fá upp svona virkni sem að virkjar þið virkilega. Og það sem OpenShift gerir þetta útgáfa þá fyrir fyrirtæki þar sem búið að pakka inn þessum open source verkefnum öllu saman og búa til rekstrarstöðu og útgáfu sem að þá OpenShift útgáfan. Og í þessu ferli þegar það kemur Kubernetes útgáfa út þá taka RedHat þarna inn til sín pakkin inn í OpenShift þar sem eru þessar 200 plus staðfestar samþettingar og að framkvæma hundruðir af lagfæringum og hraðabætingum á Kubernetes áður en að þetta kemur til þín til sem viðskiptavinnar. Og jafnframt með vottað vistkerfi, þannig að þú ert með aðgengi að fullt af container images sem þú getur endurnýtt í rauninni til þess að byggja þínu lausnir og líftímastjórnun á plattformunum sjálfum, til dæmis núna RedHat OpenShift í útgáfu 4 að þá líftíminn support líftíminn á honum í 9 ár. Og jafnframt RedHat leiðandi Kubernetes þátttakandi og búin að vera frá fyrsta degi. í því umhverfi. Og ef við komum svona aðeins ofan í hvað þú ert að fá meira heldur en bara Kubernetes þegar þú notar OpenShift, að þá sjáum við Kubernetes þarna sem gráan kassa og í OpenShift 4 þá ertu að fá í rauninni allt hitt líka. Þú ert að fá stýrikerfi með, þú færð svona sjálfvirka umsýslu í kerfinu sem að hugsa umhverfi fyrir þig. Það verið að setja upp fullt af cluster þjónustum fyrir þig eins og vöktun og eftirlit og þú ert með containerregistri og þú ert með möguleika á kostnaðagreina, upplýsingar, miðað við hvað mismunandi verkefni að taka mikið af resursum og hve dýrt það í rekstri og það orðað þannig. Svo ertu með þjónustumöskva til service mesh sem að hjálpar þér að búa til flóknari þjónustur. Þú ert með software katalóg til þess að vinna með mismunandi tungumál og mismunandi gagnagrunna og svo framvegis og svo ertu með þessa mismunandi þróunar þjónustur eins og þróunartólin, sjálfvirk building á images hjá þér til dæmis. Ef það kemur öryggisveikleiki þá getur þú látið í rauninni kerfi rebuilda fyrir þig images ef það eru veikleikar. Þú ert með CI/CD pipeline og þú ert með online þróunar umhverfi líka og svo ertu með þessa svona sjálfvirku full stack uppsetningu á alveg frá í rauninni undirliggjandi örþjónustu hýsil eða host og alveg upp í þjónustulagið. Og þú ert með þessa fumlausu Kubernetes afhendingu að þú ert alltaf með consistent plattform óháð því hvar þú hýsir. Og svo hefur möguleika á að framkvæma sjálfvirka skölun á undirliggjandi aðföngum. Sem dæmi, ef þú ert að hýst í VMware þá getur þú sagt bara ok, ef það kemur brjálað álag á clusterinn og hann annar ekki álagi, spinnaðu þá út fyrir mig fleiri vörkerum. Sama þetta að gera í Azure og AFS og fleiri stöðum. Og ef þetta sett upp. Og uppfærslunar á umhverfinu mjög einfaldar. Þetta basically bara one-click install eða einföld skipun við að uppfæra clusterinn og það allt gert sjálfvirkt. Og þetta svona dæmi hvernig uppsetningarnar á umhverfinum hafa verið háttað. Það sem að í útgáfu 3 og 4, sérstaklega í útgáfu 3, þá ertu að setja upp stýrikerfið og svo OpenShift umhverfi ofan á það. En núna frá með OpenShift 4 þá getur í rauninni farið þessa svona læstu leið sem að segja, þá setur inn í rauninni stýrikerfið og umhverfið saman sem eina heild og það í uppfærsluferlinu það læst saman. Þannig að ef það kemur uppfærsla á OpenShift þá kemur líka uppfærsla á stýrikerfið. Þannig að þú ert alltaf að læsa þetta saman og þetta getur alveg verið challenge þegar maður að setja upp eigin Kubernetes sem maður þarf stundum að læsa stýrikerfið niður eða mismunandi pakkaútgáfur og svo framvegis, þannig að það getur fyllt í dálítil umsýsla sem þú ert með laus við í rauninni í OpenShift 4. Og svona dæmum hvernig uppfærslunar munu birtast í viðmótinu. Að þú getur valið í rauninni ætlar að vera á stable release eða ætlar að vera á beta release og svo framvegis og svo setur í gang uppfærsluna og þá birtist svona eins og sést á skjáskotinu og svo þegar uppfærslu í gangi og alveg að vera búin eins og sést þarna á skjáskotinu þá til dæmis búið að uppfæra alla cluster operatора, það búið að uppfæra masternóðurnar og þarna hann hálfnaður með að uppfæra workernóðurnar og þetta gert allt á runtime, þar að segja að það alla þjónustuð ennþá keyrandi uppi og clusterin uppfærður þrátt fyrir að þjónustuna sé í gangi. Og varðandi öryggið, þá náttúrulega víðfemt öryggi fyrir gámana. Þú ert með stjórn á þessum hlutum sem eru sýndir að þú stýrir þessu alveg sjálfur og þú getur öryggisskannað innihald gámana þína, þú ert með fullt kontról á CI/CD pipeline þínu, þú ert með þitt eigið container registry og heldur utan dreifingastefnurnar og svo framvegis. Og sama með innviðina, þú ert með stjórn þar á aðgangsstýringunum hverju með að fara inn í clusterinn og aðgreiningu í neti milli verkefna eða innan verkefnis og þú ert með eftirlitið og vöktunina gagnavistunina, þar að segja stýra því hvað eru default gagnasvæðin sem að verkefnin að fá og svo framvegis og stýringu þá API-num. Og þú getur útvikað þetta með því að sækja frekari viðbætur á bara inn í öryggis ekosystemið eða vistkerfið. Nú, það er ekki allir sem eru kannski byrjaðir í Kubernetes og vegferðinni og þá er þetta svona kannski dæmi hvernig svona upptökufasin hjá flestum að menn byrja á því að fara í svona stöðulaus forrit, eitthvað sem að getur keyrt eins framenda app eins og React eða eitthvað svoleiðis sem að má bara keyra og svo kannski með tíma þá ertu farin að færa gagnagrunnin þarna inn líka og þá ertu farin að vera með stöðuháð forrit eða einhver önnur forrit sem að þarnast þess að gögnin séu vistuð og svo svona eftir því sem að færnin verður meiri þá færist það meira upp í sjálfvirka skölun og stöðuðar uppfærslur og meira svona event-drifin forritun og þannig að þetta snýst allt bara svona hvað færnin er mikil hjá þeim sem er að taka upp lausnina, hver hratt fara þessa leið. Nú, það er rosalega gott að vera með mikið starfsfólki hjá sér á vinnustað við að sinna kerfum en það búa ekki allir við þann lúksus og í OpenShift er það þannig að þú ert með þessa svokalluðu operatora sem eru svona eins og virtual kerfistjórar og þar sem þú getur sett upp valdar lausnir sem að kannski væri dálítið mál að setja upp ef maður væri ekki með domain þekkingu yfir lausninni samanber bara gagnagrunnskluster í high availability þá ertu með operator sem að getur séð það fyrir þig og heldur lausninni keyrandi og þetta er verkefni sem að RedHat átti frumkvæði í samstarfi við AFS, Microsoft og Google og það er hægt að fá meðal annars svona vottaðar lausnir hann inni þar sem að þú ert líka með support á operator lausnirnar og sem dæmi þegar það er að setja þetta inn að þá sem dæmi fyrir kerfistjóran þá getur hann verið að setja inn lausn og þá getur hann sagt ok, allir að hafa aðgang að þessu og eða eiga uppfærslunar að eiga sér stað sjálfkrafa eða þarf ég að handvirta að sjá uppfærslur af því að það er kannski eitthvað viðkvæmt þarna í þessu. Þetta er dæmi sjálfsafgreiðslu fyrir forritara þar sem hann er að setja upp MongoDB replikasett og þá er það sett upp svona þá færðu bara vissart og getur bæði gert það command line eins og væri vanur bara í Kubernetes og verður að keyra þetta allt í gegnum command line en þú getur líka gert það í viðmótinu. Nú, ef þú ert með marga klöstri þá hefur þú dashboard inn á OpenShift.com þar sem þú getur skráð alla klösterina þína og getur fylgst með þeim þar og þá er þetta vinna með öryggisuppfærslur og annað þar sem þú getur bæði sett upp klösterina registrera nýjan klöster, segja ég er að fara að setja upp svona klöster og þá færðu leiðbeiningar í rauninni hvernig þú átt að keyra það í gegn og svo getur við framkvæmt í rauninni öryggisuppfærslur á klösterdum frá þessu dashboardi og óháð því í rauninni hvar það er hvar klösterinn liggur. Og þegar kemur á forritarunum þá er OpenShift að ýta undir forrituna framleiðni af því að þú ert að fá sjálfsafgreiðslu afhendingu á fullt af tækni sem að virkjar forritaran. Þú ert með stöðugt og samhæft umhverfi óháð því hvort þú værir í skýinu eða lokali hjá þér og þú ert með sjálfvirka smíði og dreifingu til dæmis eins og ég nefndi hérna með öryggisuppfærslurnar þú getur þá patsað í rauninni rebuildað imagein þín og séð svo að dreifa. Þú ert með CI/CD pípulagnirnar og stillingastjórnunina, vöktunina og metrikana þína eða mæligildi forrita þannig að þú getur séð í rauninni hvernig forritin eru að performa og svo framvegis og undir þess öllu eru þá þessi mismunandi tungumál, gagnagrunnar, forritsþjónustur eins og þjónustumöskvar þú ert með serverless funksjónir, þú getur keyrt Linux workload, þú getur keyrt Windows workload og svo þetta keyrt allt bara í cycle, þú ert að forrita, smíða, prófa, þú ert að deploya eða dreifa og svo vöktun og eftirlit og mögulega ástæða í þessu ferli þá ert að sjá hvort það sé þörf á því að gera breytingar. Hérna dæmi forrit sem við smíðum, þetta var bara svona einfalt koncept sem við ákvaðum bara að gera proof of concept, að keyra bara innan hús hjá okkur, þar sem við splittuðum upp framenda versus bakenda, forrita React app og keyra það og nota GraphQL sem fyrirspurnatungumál og bakendin smíðar í Django sem að síðan vistar gögnin í Postgres. Og fyrir miðju sjáum við hvernig þetta lítur út í developer perspektífinu í OpenShift og lengst til hægri sá bara svona dæmi innskráningarsíðuna á þessu svona dæmi sem við höfum verið að smíða. Og eftir því sem að færnin verður meiri og maður splittar þjónustunum meira upp og þá þetta dæmi tækni sem inn í plattformnum. Þú ert með þjónustumöskvan eða service mesh. Þetta getur verið dæmi flókna vefsíðu sem að þú splittar upp í minni einingar og notar þá þjónustumöskva til þess að birta í rauninni vefsíðunni í heild sinni en kannski einhver hluti af síðunni sér vefþjónusta og þannig að ef hún bilar þá bilar ekki öll síðan, heldur bara hættir að birtast hluti af síðunni þegar sú þjónusta úti. Og þetta byggir á Istio og Kiali og Jager komponentunum í Kubernetes ekosysteminu. Og svo það serverless og fyrir þá sem að þekki ekki kannski mikið serverless þá serverless tæknin basically þannig að þú ert að skala niður þjónustunar, þær eru bara ekki keyrandi þegar þær eru ekki í notkun og þetta getur verið einhvers konar þjónusta, leið og þú kallar í hana, þá hún ræst upp, skilar gögnunum, hvort sem það kemur frá notandanum í gegnum browser eða í gegnum atburði eins og frá Camel K eða sem getur verið Kafka eða message queue og svo framvegis. Nú, það ennþá fleiri hlutir sem í boði. Það til dæmis bara svona samvinnu plattform. Það CodeReady Workspaces. Þá ertu í rauninni með allt þróunarumhverfið þitt inn í klusternum. Þá ertu bara með Visual Studio eða Eclipse, þú getur valið eða JetBrains. Þá ertu bara keyrandi það veflægt og getur loggað inn með browser. Fleiri en eitt geta unnið saman og þú þarft ekki að vera með neitt keyrandi á vélinni þinni. Og það þetta samtengja þetta við CI/CD pipelineið og þú getur verið að debugga containerinu þína með breakpoints og svo framvegis í umhverfinu bara í gegnum browserinn. Svo það OpenShift Do eða Odoo sem svona forritunartól til þess að taka kóða sem þú ert með lokali á vélinni þinni og pússa því upp inn í clusterinn. Og svo það náttúrulega bara plugins við mismunandi þróunarumhverfi eins og Visual Studio Codes eða Eclipse, JetBrains og svo framvegis það til plugins fyrir þetta allt þannig að þú ert með þetta integratað inn í þínum umhverfum. Örstutt varðandi viðskiptalegan ávinning af því að nota RedHat OpenShift að ég ætla ekki að fara í neitt detail við sendum ykkur glærurnar eftir á. En dæmi einhverja greiningu sem var gerð hjá RedHat frá 2017 og með mengi sem var mælt þar þá var að tala að það voru 164 milljónir króna í meðaltals ávinning á ársgrundvelli miðað við 100 forritara. Og rauði þráðurinn náttúrulega í þessu öllu saman að það verið að spara tíma, hvort sem það í aukinni framleiðni eða fljótari á markað eða og svo framvegis. Þannig að það fullt ávinningi í því að fara þessa lausn en það tekur náttúrulega smá tíma að koma sér svona á réttan stað en það vissulega eftir miklu að slægjast. Nú, það hægt að neyta þessara þjónustu á marga vegu. Það hægt að vera með deilt rekstramódel þar sem þú ert að kaupa undirliggjandi bara hýsingu á plattforminum og svona hluta day 2 operations af einhverjum hýsingaraðila, hvort sem það OpenShift dedicated í AFS eða hjá Opnum Kerfum, af því að við erum sem dæmi CCSP partner sem Cloud Certified Service Provider, eða þá þú keyrir það bara í eigin vélasal og nýtir síðan í rauninni support annarkvort hjá Opnum Kerfum eða RedHat eftir því sem að þér hentar og þannig að það hægt að nota þetta á ýmsa vegu. Og af hverju RedHat gott val? Og þá myndi ég nú segja í þessu samhengi ef maður að spá bara yfir höfuð í Kubernetes, þá RedHat stærsti svona þáttakandi í Kubernetes verkefninu og eftir Google og eru búin að vera á það mjög lengi og ég fór og staðfestir inn á Stakalytics að þeir eru ennþá á sama stað hvað varðar það að vera einn af stærstu þáttakandunum og þeir eru með mjög stóran hóp viðskiptavina í sínu mengi, hvort sem það eru bankar eða opinberar stofnanir og eða bílafyrirtæki eða hvað það og eru jafnframt í rosalega góðu samstarfi við alla skýjaveitur og CCSP aðila eins og til dæmis okkur og eru með þetta yfirgripsmikla hvað maður að segja portfóljó af vörum fyrir örþjónustur og hvort sem að það snýra í rauninni tækni eða þróunartólum fyrir forritara. Svona lokum varðandi þetta. Þetta traustverður Kubernetes plattform þar sem þú ert með traustverðan hýsil, þar að segja stýrikerfið undirliggjandi og innihaldið og umhverfið. Þú ert með sjálfvirkar uppfærslu þvert á stakkin. Þú ert með fumlausar uppfærslur og fullt af sjálfvirkum svona day 2 aðgerðum. Ert með consistent skýjaupplifun og ert með svona virtual operator kerfistjóra með þér til þess að halda utanum fullt af tækni í umhverfinu og getur smíða sjálfur sem sagt og hýst þetta í bara þeim skýjum sem að þér hentar og þú ert með svona nýsköpunartækni eins og þjónustumöskvana, serverless og samvinnuplattforma eins og code-ready workspaces. Og ef þið viljið læra meira á plattformin þá býður RedHat upp á learnopenshift.com þar sem þú getur prófað þessa mismunandi tækni og það til dæmis að prófa serverless eða prófa þjónustumöskva eða bara prófa einfalt að smíða eigin applicationir og á plattforminum og eina sem þú þarf þarna bara browser og til þess að prófa þig áfram. Og þar með líkur minni kynningu og í þessu samhengi vil ég segja að stafræn umbreyting fjárfesting í betri þjónustu og í sumum tilfellum geti það verið að velja lausn eins og OpenShift til þess að losna við ákveðið tæknivandamál sem að geti komið upp við að gera hlutina alveg frá grunni og valið í rauninni. Þetta eitt dæmi val. Takk fyrir þetta. Einhverjar spurningar í þessu? Að fylgjast með hérna á tjattinu eða eitthvað sem að menn eru með? Ekkert eins og þá ætla ég að svissa aftur yfir á ensku og that concludes my presentation. So, Hakan, are you ready to present?
I am, yes. Maybe you need to release control of the screen so I can...
Yeah. Let me just check.
Yeah. And obligatory. You can hear me? Can you see my screen? Yes.
Yes.
Cool. So let's kick it off. So I will be talking to pipelines, specifically in the OpenShift context. My name is Hakan Hagenrud. I just recently moved into the partner team, so I have a new, longer, impressive title. Partner Enablement Solution. It's very long. Anyway, third year at RedHat, did 2 years as a solution architect in Denmark. And previous to my engagement with RedHat, I've been in the IT industry for like 20 years in large enterprises, primarily on the other side of the table. I also did 5 years at a big science facility being built here, very close to where I live. And I picked up a little bit about quantum physics. But at RedHat, my focus areas are, infrastructure, cloud, automation, and more things. So let's dig in. I should say that it's a 3-part presentation. I talk a little bit about this, so what we mean when we say traditional and cloud-native approach to CI and CD and what's available on OpenShift. Then there is more of a technical deep dive into details, and at the end there is a demo. Right, continuous integration and continuous delivery. To put that into context, it's a process of software delivery that we sort of generally divide into 3 distinct phases. So we have the local development, some call this the inner loop, where in most cases you're using your laptop or local computer. You write your code there, you run it locally there, you may do some tests there, and then you iterate and you iterate until you are satisfied with the sort of state of your code. And in this example, you commit to Git. I mean, Git is the most common and most popular version handling systems, but I'm aware that there are others, but I will use Git anyhow. So once you commit, this usually initiates the sort of second phase, continuous integration, where the commit triggers, or usually I should say, triggers a pipeline of some sort in some kind of CI engine, where your code, gets built and some kind of integration test possibly run, and usually it packages up your applications into a package that then can be consumed by other environments. And with this, we can create a release and enter the third phase, the continuous delivery phase, which really is an expansion of the CI to focus more on deployments. I mean, to deploy your application into different environments, and this can be done automatically, and so at some places they, for the final step, release into production, can introduce some manual approval steps. So, I mean, the traditional CI/CD, I guess most people are familiar with, but what do we mean? What do we mean when we talk or say cloud native CI CD? And yes, there's loads of buzzwords, but firstly, I mean, it is adapted and built for this cloud native world, and containers are, first-class citizens in these kind of solutions, and even the solutions themselves usually run on top of Kubernetes. Serverless, I mean, unlike traditional solutions, there is no central server to manage, and managing of that adds operational overhead. Serverless can be part of the Kubernetes platform, as in built in, so you can declare your pipeline in YAML, specify how the pipeline will execute, off it goes, and it does its thing. And when the pipeline run is done, no resources are needed for the actual pipeline, so it can actually scale down then to 0 and free up resources for other parts. And for sure, finally, they are built with the DevOps, the DevOps in mind, the DevOps mindset, embracing this idea of microservices and distributed teams or self-autonomous teams, whatever you call them, these kind of teams. They want to own the application delivery. They want to control how this application delivery happens, what goes into the pipeline, what kind of plugins are used, without being limited by this sort of central team managing a pipeline engine for them. So what's available in OpenShift? We support both of them inside OpenShift. Jenkins has been part of OpenShift since the introduction of OpenShift version 3, which was at the end of 2015. And Jenkins continues to be a supported way of doing CI/CD within OpenShift today. But to accommodate for this DevOps motion, we recently started to make a product out of an upstream project called Tekton, and this focuses for sure on the cloud native side. And just to reiterate a little bit about the differences, traditional Jenkins in this case was introduced in February 2011, so that's a long time ago, 10 years ago. So it was engineered for virtual machines, and this architecture more or less requires you to manage this CI engine centrally. Many organizations have built dedicated teams to manage this engine. Plugins are usually shared across the same central platform. You need to have care to be a bit careful when you introduce new plugins or even when you update existing plugins, and because it's a shared infrastructure, right? And when you update plugins, even some plugins have dependencies to other plugins, and they are not managed as a whole. So again, we're creating admin overhead. And it was not built for the cloud native world. 2011, not that many people were using containers. and finally, a final point, persistence of data, needs to be managed again by the same team on the traditional side. If we go to the cloud native side, for sure, it was designed for Kubernetes. Containers are naturally a first-class citizen, and you do not need, operations to manage the pipeline. The pipelines are fully isolated from each other. Every aspect of the pipeline is formed and built from container images. This for added flexibility and empowerment of, those autonomous teams. And it's, a native Kubernetes service, so we can utilize the platform to manage persistent storage, as we do with any other Kubernetes service that needs persistent storage. So let's talk a little bit to the use cases, looking at the time. So when I talk, I realize it sounds like cloud native is the only way forward. But there are many cases where either one of these are a better fit and makes sense. And I've just listed a very, very small subset of these. So, some organizations do want that sort of central governance you get with the traditional CI/CD, as it enables controls of, control of versions or versions of plugins or libraries or specific libraries. And for sure, these same organizations have a long experience managing and utilizing a tool like Jenkins. They may even have created their own plugins or, specifically homebrewed libraries for their, traditional CI Jenkins. And final point, you may not even target Kubernetes. Why go down the cloud native route? But if you're targeting Kubernetes and you're aspiring to do, like DevOps, build these autonomous teams with the microservices architecture, a tool like Tekton, the cloud native CI/CD, would be way more suitable. Yeah. Final point, you get pipeline as a service, so you consume it and then sort of it goes away. Cool. So we now enter the more sort of technical details on Tekton. And what is Tekton? This is the upstream open source project where we and Google and CloudBees and others are actively contributing. It's governed by this continuous delivery foundation where we are also a member. And it's designed with these principles in mind, right? So we have the declarative Kubernetes native way of making making pipelines. Serverless is part of the architecture for sure, and the isolation of pipelines. But I have not mentioned the portability of these pipelines, which is the third bullet on this slide. So Tekton is it's a standardized extension of Kubernetes, meaning you could use and reuse any pipelines you create and use on OpenShift on any Kubernetes platform, as long as the Tekton extension is available. And for sure, we also make some plugins for popular editors available. And there may be some diehard command line fans here, like I am. So there's a dedicated CLI, a Tekton CLI, to interface with your Tekton pipelines. Right, some Tekton concepts. It's fairly simple. I mean, the end goal here is to run pipelines on top of OpenShift or on top of Kubernetes in a native way. So some concepts. I mean, a pipeline, which is the whole, right? So this is how you declare how your pipeline should look. What tasks need to sort of be done first before moving to the next task. Also, you get to choose if tasks are executed in sequence or in parallel. So, imagine you're building an application, you would like to run some tests, linting, unit tests perhaps. These tests don't really have a connection to each other. So, for the quality of your code, if either one of them fails, you would have to rewrite or fix the bug or the problem that you created in your code. So for tasks like these, you can for sure use the parallelism, run them in parallel, meaning you're saving time for the entire pipeline run. For pipeline runs typically take time, quite some time, as you know. Right, so once you have defined what your pipeline should look like, then you instantiate this with a pipeline run. So a pipeline run is when the actual pipeline is running. So you get a start time, you get some kind of results, and these results are then stored for future reference. And then quickly, what then makes up a pipeline is tasks, and a task can then contain one or many steps, right? So steps are the sort of base component, and it's just a command or a script that executes in a container. You also have all the Kubernetes constructs available to configure this container in any way you like, using environment variables, config map secrets, whatever you like. Since it's containers, you get to choose the language or the scripting language that you want to use. You just need to point to the correct container image. And then we collect these sort of steps into tasks, right? So a task needs to be a specific task, do more or less one thing, but you can have many steps to accomplish this. As you can see here on my screen, maybe I can use the pointer. Yeah, cool, I can. So this actually contains two steps, and they are: first, build the code or build a binary, and then push it to some repository. In this case, it's at quay.io. And steps always run in sequence, very similar in concept to an Ansible playbook. If you're familiar with our automation framework, Ansible, same concept, top to bottom, no exception. And this makes it very easy to build, your task with these steps that may, have some kind of dependency to each other. So always from top to bottom. And the last point here, try to make them reusable by not inputting, hard coding stuff that is very tightly connected to your project. Because these tasks, they can exist in your local project where you are developing, but you can always, also make them available in the entire cluster or to your entire organization, so you can share tasks. And we have taken some inspiration from, again, from Ansible Galaxy. So there is something called Tekton Hub, where people are sharing their tasks with other people on the interwebs to promote reusability and collaboration, right? So a really important part here is the collaboration. So if I upload a task, some people may start using it and they may actually add stuff to it that makes it better. So then without me doing anything, my task becomes even better than than what it was when I started. So let me just show you briefly what is Tekton Hub. So it's a very, very simple but fairly substantial list of tasks that you can browse. You can have a look on, I don't know, some kind of language, Python for instance, and then you get some instructions on how to install this task and how to use it. So it's a very good way to kickstart your pipeline experience, if you like, on OpenShift. Get going quickly. Don't reinvent the wheel, and possibly upload your own things, and then you can get input on how it works. Right. So let's return to the Tekton concepts. So to tie this all together, we have the pipeline, right? So this is the template for the pipeline runs. So you connect tasks into some kind of workflow. Tasks again can run in sequence, or they can run in parallel. I mean, perhaps you remember when I talked to the linting and unit tests, right? Can run on any worker nodes, and you can use conditional statements, like if this is true, then continue and do that. And it's possible to share data between tasks. So your pipeline can, get access to, or you can give, using the pipeline, access to a shared area for tasks. And this is fairly new with the OpenShift pipelines. It's called workspaces. Sorry. The workspaces is just more or less a file system available for all of these tasks. So my example is very simple. The first task will download using git clone the source code. So you only need to do it one because it gets added to this workspace, and then I can allow access to this workspace for all the tasks, so they don't have to re-download the same code again. Yeah, I promise just a few more slides, then it's finally time for the demo. So another addition we recently added to pipelines, or OpenShift pipelines coming from Tekton, is triggers, which is more or less like a webhook. If something happens in your Git repository, a push or some other kind of event, it will trigger a pipeline build. And just to reiterate, we provide plugins for popular editors like Visual Studio Code. There is a command line interface directly to Tekton for, again, people who prefer using the CLI. And there is also a plugin specifically built for IntelliJ. So a very quick recap, and then demo time. Built for Kubernetes, runs on OpenShift. We package it up in an operator, so it's easily consumed. We contribute and deliver some tasks that are available to use immediately. And then we integrate with our developer console, with the Visual Studio Code, if that is what you use. And yeah, more or less, this is what we talked about when we talk about Tekton. So let's move into the demo part. Can you still see my screen? Yeah, Yes, no?
Yes, we can.
Thank you. So every time you shift, you need to make certain. Right, so this is the OpenShift console, right? And operators, where I've just mentioned, this is how I'm logged in as the cluster administrator, so I have rights to extend this cluster. I have already installed the pipelines operator by clicking the install button, and it gets installed. And what happens is that it extends the user interface with this portion, pipelines. And if we then move over to the developer view, so the developer console, I previously, before kicking this off, deployed an application, which we are now anticipating the waiting for. Yes, here we go. I don't know why it was slow. So I did this by using a very simple workflow add from Git, and I pointed to my Git repository, which contains my exceptionally simple PHP application. This is using something called S2I. So in this repository, there is nothing more than the PHP code. I select some image to run my code on, give it a name, and come to this portion where I add a pipeline. So I did this previously for my application here, which is called my front. So I can go to the pipeline portion. And here is this sort of boilerplate pipeline that I gotten when I check this checkbox. Please provide me a pipeline, and it's actually been used. So it has done an instantiation of a pipeline run, and we can go in and look at how this went. Yeah, looks like it did, good things. Right. But now what I would like to do is add a task where I actually run some simple test to this pipeline. So I would like to add this linting task. So it's just going to check. I mean, it's in essence, a linting does two things. I mean, for sure, it checks whether or not this code can be, considered good good practice by linting, but also actually it checks if there's any syntax errors, right? So it's actually quite a good thing to add. So I will add a task, a regular task, and I have prepared this beforehand, as you might imagine. So tasks are defined in YAML. I'm just going to add this without talking too much to this. And you can have tasks which are available in my project, but we also provide cluster tasks. And you can also define cluster tasks, again, to share across your organization. So let's go back to the pipeline and add this. So we go back here and we go back to my pipeline. And we go to edit pipeline. And I would like this to run after I have git cloned my repository. So I'm putting it here and I'm adding the PHP linter. That's it. It's now added to the pipeline. So we save it. And then I realize, oh, I need to do another addition. So I go over to this YAML view of the same. So you can either choose to use, as I do, buttons and things, which are very nice. I would need to add this portion to the linter. So for some reason, this gets minimized. But this is all I need to do. I just need to say that, yes, this task that is going to run also has access to this shared workspace, right? And so you have these two ways of working and editing with your pipeline. How are we doing for time? I think there should be 5 more minutes.
Yes, that's correct. You've got
cool. So I'm perfect.
4 minutes, but That's okay.
That's okay. Yeah, cool. So I'm on time. That is great. So now I've added this to my pipeline. So now I want to, trigger another run, and just press start and off it goes. Right. So while that is working, let's look at extending this pipeline a little bit more. So now I have added, after the repository getting, it's going to run the linting, then it's going to build, and finally it's going to deploy this. But maybe we should add some more tests, for instance. So let's add something like performance tests. These are just examples that I previously put in, and integration tests. But just to reiterate, these two can run in parallel, because if either one of them fail, the pipeline run is considered a fail, right? So they can be run in parallel, whereas the other ones needs to run more or less in sequence, right? So I can add that to the pipeline. And final point I want to do is, once this pipeline actually deploys my application, I want to check to see whether or not this application is running. So again, let's go back to administrator part, pipelines, tasks, and add a task. So now I'm just gonna show you. Is this visible on the screen? Yeah. So this is a very, very simple task, but it still illustrates a few things. So it's based on this image, which it downloads from our registry. It runs a script within this container image, and this script is fairly simple. It's a shell script. It runs a curl command, and it needs to know where this service resides. So here is a variable that is available upon here in the parameters. So how does this then connect to my pipeline? So let's go back to the developer view and the pipelines, and it's still working, which is great. So add this to the end. Let's make an edit, and at the end of this deployment, we want to run this final test. Is the app up? And when I select this task, you can see it becomes red exclamation mark because it needs some input. And in this specific case, it needs the service name. So I'm just going to input my front and press save. And that's it. So this task, this app respond, I could possibly share with others in my organization who needs to do a similar test if their application is running or not. Cool. So that was the end of my, so that is still running. End of my talk and end of my demo. So do we have any questions? So I'm gonna stop sharing my screen then. Shoop. And there were no questions in the chat. No? Cool. So then I guess it's time for coffee break, right?
Yeah, that is correct. And
we do.
Okay, awesome. Thank you very much. So hi all. First of all, thank you very much, Opin Kerfa and Samúel, for giving me a chance to be here today and speak. So my name is Rasheed. I am CEO and co-founder of Stakater. We are a fully focused company that specializes on Kubernetes. I'm myself a hardcore techie but also, and I love to write code and deploy applications on Kubernetes and on OpenShift. And as Samúel mentioned, that we are a premium RedHat partner. We are based in Sweden. Stockholm. So Stakater as a company, as I mentioned, we are specialized on open source. We are helping companies to realize the full potential of Kubernetes when they are doing some digitalization or integration on top of Kubernetes in their journeys. Could it be the strategy, development, or operations, that how they can use platforms like Kubernetes and platforms like OpenShift to really reap benefits when they are trying to look into modernize their applications, or they are looking to modernize their integrations, want to do IoT or any kind of that kind of stuff. Some pretty quick facts about the company. We are, like, as I mentioned, headquartered in Sweden. We are like a team of 25 people, certified, and what we call ourselves, rock solid developers. So we are not an administration company, but a developer company who has fallen in love with Kubernetes and has been helping organizations in their journey to use this awesome technology. We are an open source contributor. We have built 20 plus Kubernetes OpenShift add-ons, have more than 5,000 GitHub stars. So we are very active in the community as well, building and sharing solutions with the community which runs on top of Kubernetes or OpenShift. So I might use the word Kubernetes more than OpenShift, but I think if none of you know, OpenShift is an enterprise-ready version of Kubernetes, and Kubernetes is what you call the upstream version. But we use the words interchangeably. So I think the question comes like, what are today's IT challenges? And today I will talk about our solution that we have built and that we are running with our customers. Is that IT is under tremendous pressure that they need to, what you can say, enable growth. And on the other hand, business, they want more and more innovation, but the infrastructure that they have, that IT has, is not capable of supporting that. So the innovation, the IT, what we call innovation gap, is actually growing. So rather than that business demands more, IT is not able to deliver based on their expectations. So they need to come up like new ways how we can deliver, and cope up with the demand of the business, because they want new apps. So we thought about, okay, there's a challenge. We need how we can really solve this gap thing. One thing that we need to look at is that if you look in the market right now, that's what we have seen in the last 5 years since we have been working, that 3 different things are happening at the same time in the market. So if you look in from the architecture perspective, companies or organizations are moving from like monolithic to microservices. You might be hearing that word a lot, like make small. And then for delivery, they are moving away from what you can say waterfall to DevOps kind of methodologies and way of working in Agile. And for infrastructure, things are moving from physical servers or VMs to containers. So you can say these 3 different things are happening at the same time. And it's very important that all those things are aligned within the organizations. So we have seen a problem that like IT, like the architecture, they want to go to microservices, but then they don't have the underlying infrastructure to support that. Or maybe they want to move away from waterfall and get into DevOps, but they don't have the underlying infrastructure, or the architecture doesn't agree. So what we have learned in our experience is that it's very important that these 3 things will happen at the same time, and they have to be very well aligned. So you need to put an effort for alignment of these. Otherwise, they will be forcing against each other. So in order to kind of solve this journey, we figured out that based on our experience working with a lot of customers, that they have ideas and they want to go towards product. Okay, so they have an idea, they want to go towards product, and the question is, okay, how do we go to that product? There you think about in terms of okay, if I have an idea and I want to go towards a product, you will think about, okay, I need to have some sort of underlying solution that I can use, so that I can reduce the cycle time from idea to product. So you will have different kind of stakeholders, You would like to have different kind of environments like dev, QA, UAT production. And then you have different kind of cross-cutting concerns that you need to take care of, like monitoring, scaling, self-provisioning, and all that kind of stuff. And in order to resolve that, so Stakater, we have built what we call App Agility Platform that is based on OpenShift, but we offer it as a fully managed service. That basically enables that if you have an idea and you want to go towards a product, you have the underlying infrastructure or the base that can enable you. So if you want to go towards microservices, you need the underlying stuff. You want to go towards DevOps and Agile, you need the underlying solution that will support that requirement. So that's what we have built. So in a nutshell, what is an App Agility Platform? It's a fully managed DevSecOps platform on Kubernetes for teams so they can focus on their product. So we have built this platform which has underlying uses OpenShift as the enterprise Kubernetes distribution, but then we add a lot of other add-ons on top to make it a complete DevSecOps platform. As you might have seen, that Kubernetes has really revolutionized the industry, and it's being used as a reality for multi-cloud and hybrid stuff. So, I mean, there are like use cases where we have worked ourselves with the customers where they have taken benefit from using this technology, like not like just a technology, but real business benefits. And they can be found across all different sectors in the industry. Could it be healthcare or retail or shipping? There are benefits all over the way, that you can use from this technology if you know how to use it in the right way. I mean, if you are familiar, like if you start looking into Kubernetes already, I would like to present this analogy so that you can understand, okay, why can't we just use Kubernetes? Why do we want to have a full DevSecOps platform? So if you take an analogy of a car, actually, inside the car, you have an engine, which is like the one piece of the puzzle. But if you want to build the whole car, you can do that definitely, but then you have to pick all the pieces yourself to build up the whole car. So it could be the tires, it could be everything around that you have to go and choose and select and then put together and make sure they can work together. So it's an awesome journey, like to build a car. And at Stakater, we have been doing that for the last 5 years with a lot of our customers where we help them to build this car. But then on the other hand, the question does come, okay, are you looking for just container orchestration or are you looking for a car actually? So what we instead, offer, what we said is our platform, which is a managed DevSecOps platform. And in this platform, we are saying engine as a service versus as compared to car as a service. So you get a whole DevSecOps platform, which includes everything with the chauffeur so that you can just ride from one place to another. I mean, what we have seen in our experience with all the customers who start working with Kubernetes, that they don't just want to use it for container orchestration. They also want to use it for other things like monitoring, logging, secrets management. They want to run everything on top of Kubernetes. And that's where the actual complexity lives, So you might wonder, how do you define a DevSecOps platform? So let's say you run a Kubernetes cluster. I mean, it could be anything. I mean, you can run any sort of Kubernetes cluster. But if you want to make a full DevSecOps platform on top of Kubernetes cluster, you will need to run what we call application lifecycle management tools, which include CI, CD, secrets management, configuration management, artifact management. You will have to learn platform observability tools for metrics, logging, choice mesh. And then you have to run tools for security and compliance. And then you have to take care of automation and management, like backups and upgrades and everything. So that's what if you want to make a complete DevSecOps platform on top of Kubernetes, that's what you will have to run on top. So either you will run those things yourself outside of Kubernetes, or you will buy those services from third-party providers as managed services. But then that's how you will define a complete DevSecOps platform. Otherwise, if you're running just Kubernetes, that is only one part of the puzzle. That is only container orchestration. But in our experience, everyone wants to build DevSecOps platform. And what you have to keep in mind is that each of these tools that you run on top has a life cycle. You have to first find, install, configure, enable SSO, troubleshooting, patching, upgrading, and depreciation. So you can run all of these tools on top, but then of course you have to keep in mind that all of them have an operational lifecycle on top. So what we do in our fully managed service, we have picked these best of the breed tools, like I would say 70% they come as part of OpenShift, for example, but they are not but we run them and manage for our end customers, but then we add the missing pieces on top, for example, artifact management, secrets management with the Vault, and tools like Falco and those kind of, like OOP, Gatekeeper for security enforcement, Velero for backups. So we run all of those tools on top and then offer our customers a fully managed solution. But underneath, we use OpenShift enterprise distribution as the base for Kubernetes. Reason being, we have been working with Kubernetes for long, and definitely OpenShift is the best enterprise distribution. Another way, to just present, if you want to build the DevSecOps platform, you take Kubernetes, you need to do cluster lifecycle management, multi-tenancy, single sign-on, backup, intrusion detection, image scanning, policy enforcement, CI/CD, secret management, artifact management, code inspection, monitoring, logging, tracing, alerting. So that's another way to look at, what does the Stakater App Agility Platform offers, that we offer all of these as fully managed in one box to our end customers. And then, of course, the team customers can focus on team onboarding, creating pipelines. As Hakan showed, you can focus on creating pipelines, troubleshooting pipelines, and cloud integrations. If you want to run it on any cloud, you can work on those stuff. So you don't have to work on the basic thing that's included or available as a commodity. So just in a nutshell, so underlying, we offer this service on the public hyperscalers and OpenStack and VMware clouds. And we offer these platform services, operation services as together. And then we let our customers focus on what we say, the application lifecycle management. So you can focus on running the containers, like building your applications. So definitely Kubernetes and OpenShift are awesome platforms, but when it comes to running them and having a full DevSecOps platform, that's where the complexity kind of lives. And that's where you have to be mindful when you're running these kind of technologies. I might kind of skip this, but, so what are the benefits? What the benefits basically: faster time to value, operational overhead, empower the developer productivity, is flexible consumption-based pricing, accelerate development, security, cloud-ready, everything, and then kind of, self-service where you can run everything as code, GitOps approach. You might have seen this before, but I think the key thing here is the developer productivity, that how you enable developer productivity from build, test, deploy, monitor, review, and code. So that, and this is kind of that things that you can get from the OpenShift as a baseline to be able to do this stuff like CI/CD, configuration management, and the self-service provisioning. So I'm kind of done with my slides, and I tried to keep it a bit fast so that we can take some questions if people have anything. So I would like to take up those questions. So I'm going to switch back to the Teams and see if there are any questions for anyone.
Not at the moment, it seems.
Yeah, nothing at the moment. Yeah, but I think I'm on time, right? I had time till 12:10, right? Yeah.
Yeah.
You actually have 10 minutes.
Yeah.
I think.
Okay. Okay, good.
Yeah. And thank you for a nice presentation, and looking forward to do some additional work with you, Rasheed, on this platform.
Yeah, definitely. Yeah.
I think we can basically, if Eero is ready, then we can basically go to the next presentation if there aren't any questions at the moment.
I'm good to go if there's no questions.
Okay. So feel free to overtake the presentation when you're ready.
Perfect. Yep, can you guys see the presentation now?
Yes.
Okay, perfect. So, hello everyone, and thank you for sticking around till my piece. The title of my presentation today is Future Finance Data Innovations with Open Banking. So let's start off by introductions. So my name is Eero Arvonen. I'm currently working as a strategic architect, whatever the heck that means, at Enento, where I've worked since early 2016. My background is in Java development. I started coding professionally about 10 years ago. I was the lead architect in a pair of projects that produced our first open banking related product, which you'll be shown and talked about later today. So I'm representing Enento Group, which consists of Suomen asiakastieto in Finland, UC in Sweden, and Prof in Norway and Denmark. And we are listed on the Helsinki Stock Exchange. So who are we and what do we do? Well, we are one of the leading providers of business and consumer information services in the Nordics. We collect data from various sources, such as the government, private businesses, and consumers, etc. We process and combine this collected data to provide our services. Obviously, we're also a fintech company, always looking to bring new data inventions into the market. Examples of this include our ESG report service and most recently, of course, our open banking solution. In brief, our products and services are primarily used for risk management, finance, administration, decision making, and for sales and marketing purposes. Okay, so you're at your home office, all cozy, right? So you could just, let your mind drift or play with your phone a little bit and maybe read some emails, right? Well, before you do that, let's throw a few questions out there. Why do you think my company and I guess companies in general are interested in open banking? How do you think open banking currently affects consumers, perhaps consumers like yourself? And how do you think it'll affect you in the future? I mean, we are barely scratching the surface so far. And also, wasn't this event supposed to be about OpenShift? Where does that come in? So if you know the answers to all of these, then good, you're dismissed. Grab your phone and read some emails. But otherwise, keep listening. Okay, so let me tell you why open banking is interesting to us. Let's wind this back. After the financial crisis, we've had plenty of brand new regulation in the financial sector. You can see all the acronyms here on the right. There's KYC, there's AML, there's GDPR, and late 2019, of course, we got PSD2. Now, PSD2 is basically the thing that kickstarted open banking here in Europe. Now, for Enento, new regulation brings new business in two ways. First off, banks have more need for our existing risk management services because regulation demands it. And secondly, and this is the case with PSD2, we gain access to new data sets as a result of new regulation, and we can then build new products and services on top of it. Financial institutions, however, are getting the short end of the stick because this will drive up their costs and might disrupt their business models. So what fintechs such as us need to offer is automated solutions on these new data sets via scalable technology. And since we are competing in a regulated sector on a business that requires trust, we need to make sure our solutions are compliant. So why are we interested? Well, we are interested because there's a brand new data set we can combine with some of our existing stuff to help our customers make better decisions. So then, a few words about the service we've built called Account Insight. We've been live since, well, PSD2 went live, so I guess almost 1.5 years. But one more thing before we get into the nitty-gritty. We are a privately owned company out to turn profit, obviously, but I want to highlight that our mission is also one of positive impact in society. So let's have a one slide recap of what it is Enento does. Our battle is against over-indebtedness in the Nordics. And this is what the service does. It accesses the bank account data of a loan applicant, payment service user, PSU, based on their consent. It processes the bank account data in the context chosen by the PSU on behalf of a creditor. It delivers actionable results or facts regarding the applicant's financial behavior, and this is all done in a compliant way. And by compliance, of course, I mean PSD2 and GDPR. So here are some of the facts we produce in real time from the bank account data. First one is ability to pay and cash flow. How much money you currently have and whether you're able to bring in more money than you spend. We verify income sources and IBANs. According to a poll we did, income verification is actually the #1 thing our customers want out of this service. And thirdly, we can calculate plenty of other facts, a bit more minor facts, I guess, but such stuff such as whether you're likely to own a vehicle, likely to own a house, how much you gamble, how many children you have, etc. And my favorite is one that calculates the percentage of your net income that you spend right after payday. And you could see how that might affect your creditworthiness, right? And now we are getting to the technical side of things a little bit. So here is our design philosophy. So we have a private OpenShift cluster, and therefore our starting point was that we were going to run the service as containers on OpenShift. And based on that, of course, it's quite natural to have a microservice architecture. We went with Thorntail, aka Wildfly Swarm. We have been running EAP at Enento, especially in the Finnish branch, for quite a while. And Thorntail is basically Java EE compliant microservices, and we saw it as a natural evolution for us moving into containers. Now, this slide is slightly out of date, of course. We have since migrated large parts of the Account Insight service onto Quarkus, which is a even more, cloud native Java framework. We picked React and Node.js to run our front end on. And since we were able to run with the latest Java 11 back then, of course we did that as well. And this final bullet is actually something that came from our product owner, who was a non-technical person, and what she wanted was something she called joints. So what I mean by this, or what she meant by this, was that first of all, we are working with a partner to access the APIs the banks offer, but it might be that we want to access banks that are not available through a single partner, or might want to build direct bank accesses. So there has to be this flexibility in terms of that. And there are actually many interesting parts in the whole process of the accessing the account and doing the calculations on it. There's the fetching of the data. That's one part, and then there's the part where we download. Calculate things out of the data. So, what if we had a service we wanted to integrate that already somehow had the data and just needed the calculation? Or maybe the other way around, what if we wanted to integrate a service that just wanted the data and not the calculation? And so this is the kind of stuff we wanted to think about in advance, because we really think the solution will run for a long time and, of course, has to be future-proof. Now, surely you can see the interplay with these bullets, right? I mean, containers go hand in hand with microservices. Thorntail and Quarkus is just Java EE microservices, and these joins just highlight the fact that we cannot afford to build a rigid monolith, so we need some separation of concerns. And also a quick word about how we worked with the clients. First of all, we broke new ground at our company with the amount of cooperation with our clients. We had regular workshops with our pilot customers, and they gave us meaningful input into the design. We utilized Scrum with 2-week sprints. Scrum worked great. We also did code review for the vast majority of our code commits, and pair programming was utilized daily. And we got the test environments released to our pilot clients before production was online. And unfortunately, sometimes it goes the other way around. So this is the application architecture of Account Insight. We have a grand total of 8 microservices. We have a database and we have a cache. And the production version is run in about 20 or so container. Let's also introduce all of the parties at this time. So there's our customer, aka the creditor, here on the top left. Then under the creditor, there's the end user, the PSU, that accesses our system via browser. And finally, there are the banks from which we download the account data. Now, the banks are obviously not in this picture. That's because generally we don't want to actually use our resource to integrate bank APIs, but rather opted to partner up with Enfuse, who does this for us. And all the banks we can currently get data from are there for access through a single API. And Enfuse is here on the bottom right. And the whole thing is running on OpenShift, of course. Okay. Let's go through these microservices a little bit to see what they do. First of all, some of the microservices affect what the process flow will be like. The service called interface PSD to REST here at the top controls the flow from the creditor perspective, the PSD to client from the PSU perspective, and the orchestrator from our perspective. And by calling each other, these 3 microservices move the process forward one step at a time, depending on, whose turn it is to give input. So let's say we wanted to alter the flow somehow. The rest of the services simply wouldn't care. We wouldn't have to build them, we wouldn't have to redeploy them, and we wouldn't have to retest them either. And any change to the flow would only affect roughly 1/3 of the whole service. And this is pretty convenient. And then there are a couple of services that affect the calculation. One is for the mathematical portion. The benefit of decoupling the calculation is actually pretty useful. Basically, we can change the data schema without any hassle. So let's say we added a new fact we wanted to calculate. Well, the other services wouldn't really care about the change. The other service here is for matching companies, the one called Company Matcher. You've probably taken a look at your own transactions in your own bank accounts, right? Well, at least for me, it's not always trivial to deduce the actual counterparty of each transaction from the field you see in the web bank overview, right? Well, there's a microservice for that logic as well. Now, with this structure, we've also achieved some reusability. So let's say someone had the account data and that they had acquired elsewhere and not through our process. Well, you could now do the same exact calculations without using the rest of the flow. Or let's say there's a completely different service that also had company names and wanted to find out the business that they do. Well, with the company matcher, they can do exactly that by one single API call. Also, thanks to it being a microservice architecture, we can scale these things separately. The calculation is the most CPU heavy thing we do, and we can scale that part atomically instead of the whole thing. So we decided to partner up with Enfuse for bank accesses. And we did it because they have integrations with many banks, and we wanted to use our resources to build the rest of this service. There's one microservice for each direction of communication, and none of the other services really know about partner or bank-specific stuff, such as data format or addresses. They just know which service to call for a certain bank. Currently, it's just this one, but we could expand our repertoire without compromising any of the ones that already work. This also makes the PSD to type bank accessing reusable. I mean, if we had a service that just wanted the data, it would be very easy to just have that. And finally, there's a mechanism for logging stuff for the purpose of audit trails, basically. Nothing major here, just that the main flow doesn't really have to care about it. Okay, so with that, I'd say it's time for the demo. I will say, though, that we are now going to access a sandbox that is built on a sandbox and that I'm accessing via VPN. So in case something goes wrong, it's totally not my fault. Okay, so this ugly thing here is not the service. This is actually our testing tool called Sample Bank. And I'm about to start a new session here. Let's set this to null value first. So basically this here is the schema of the call a creditor would send us to start the account insight process. So for instance, there's the name of the service that affects which rules are returned. There's also a set of callback and redirect URLs, and these are for determining where we set the calculation results and where we return the end user after the process has terminated at our end. So let's send the application and see what happens. Okay, as you can see, we have now moved to a new tab. We are now out of Sample Bank and are following the flow from the actual end user's perspective. So let's actually do English here. Okay, so here we're going to give consent. We can read the terms and conditions another time because no one ever reads those, right? We're going to click accept here and we will get a list of banks. Well, these are Finnish banks, obviously. We're going to pick this one for our demo here and pray that it actually works. So now, after choosing your bank, you would do your strong authentication, right? Let's see if I remember these test credentials here. This one, I believe, is, yep. Okay, so now we've done the strong authentication, and now the end user, the PSU, would get opportunity to choose which accounts they want to authorize. So we're going to authorize this one with 5,000 euros in balance. Perfect. So the data has now been downloaded, and as a consumer, we would be returned within 1 minute to the creditor from where we came. The PSU also gets the opportunity to review their own data. This is just JSON, but this is basically all their bank transactions. You can see the 5,000 euro balance here that we just saw, and then there's a bunch of transactions here. Transaction date, counterparty name, and transaction amount. from the last year. So yeah, so this would terminate the process for the PSU, but of course, under the hoods, we've now done the math and sent them to the creditor, right? So let's go back to sample bank where we click get latest rule engine results, and here we go. I'm actually going to copy paste this into a notepad. So as I mentioned before, the number one thing that creators are looking for in this service is income verification. So there is a rule called employment here. So based on recurring transactions that our system found in the account or accounts that were authorized, our application has determined that the PSU's current employer is a company called Tilupalvelut Oy, and their current net salary is about 2,500 euros per month. And there's some more specific data here, such as standard deviation. If their salary has a high variability, then or variance, then well, it's more risky and that sort of thing, and length of employment and all this, number of missed months. So this is one of the data points that our customer can get in an automated fashion from this service. Okay, and that, I suppose, concludes the demo here. So let's jump back to the slides. Okay, so let's talk about benefits we got from working with OpenShift on this one. So setting up a Git project, a build pipeline, and a new deployment for a new Thorntail or a Quarkus application only takes a few minutes, and I would say this lowers the boundary to actually decouple stuff. For us, it takes less than 5 minutes to go from a code commit to a client test environment, and well, even to production if we dare. Containers and microservices give us the freedom to choose our technology because we are not restricted by existing infrastructure. With a replicated in-memory database for sessions and deployments of 2 or more containers per service, we never really have to have downtime. Sorry about that. Of course, all of these bullets translate to concrete business benefits, which can be highlighted as we go. I mean, quick setup means basically saves time, and time is money. A lower boundary to decouple stuff, well, that should be higher quality. Quick deployments means faster lead times, shorter feedback loops, and freedom of choice in technology should mean better quality, better productivity, better security. No downtime and easy scalability means better user experience and lower cost of maintaining. Also, it was good to see that within the development team, we got great enthusiasm about the fresh technology and cool technology the developers were able to utilize this time around. Okay. So let's talk about the future a little bit. I'm gonna list out some of the new service initiatives we have cooking around this thing. So first of all, this is my favorite one. We could basically flip the script on this whole thing and go to a totally new direction. That would be enabled by saving the transactions we download from the bank, except we anonymize them first, of course, because otherwise it would be GDPR compliant. Now, we would like to save some information on them, including maybe age, gender, and approximate location. And after we do, let's say we did 1 million sessions like the one we just did and anonymized and saved all the transactions. After that, we could come up with facts such as women aged 20 to 34 prefer H&M to Zara in Stockholm, 77% to 23%. But Zara's been gaining market share at a steady rate per quarter since 2015. So this is something we are actually trying to get done, and we could sell this data obviously to any business. Also, we are working on a My Data Type platform at the minute. So basically, you do the same thing, and we offer the same type of results to the consumer for the purpose of personal finance management and telling the users basically what their credit rating is and how they could make themselves look better in the eyes of a creditor, which type of changes they would have to do and that sort of thing. Finally, there's income verification. So like I said, income verification is the number one thing our creditor customers want. But there's other purposes for income verification as well. For instance, here in Finland, at least, when you are trying to get a rental apartment, what you generally might do is you might go to your web bank account. You might take a look at your payslip there, and you might like export it as a PDF, and you might attach it to an email that you sent to your landlord, right? Well, that is not automated, and it's not secure, it's not reliable. It's actually a pretty bad solution. But we already have a solution that could be used for income verification, for instance, for rentals or other things you need income verification for. So we're actually looking at incorporating this process to other use cases where income verification is necessary, besides just applying for credit. And I believe that wraps up our presentation here. We do have some time for questions since we started early. So if anyone has any questions, now's the time.
Thank you, Eero, for this nice presentation. Maybe one question from me about did you see any big improvements in moving your Java-based applications to Quarkus, for example?
Yes. So, well, I do have a couple of slides on that I could actually present if you'd like. Since we have a couple of minutes, I could dig those numbers up actually. Let me just open it up here. I mean, well, okay, now I got it. Just give me just a second here. So moving to Quarkus. Excuse me. So yeah, this is the first application we moved onto Quarkus from Thorntail. The large sized bar here, the white one, I guess. So let's go back a little bit. So first of all, there's 3 deployments I made for this application. One was on Thorntail. The second one was on Quarkus on JVM, and the one on the right was Quarkus compiled onto native. And well, the image size of the artifact went down from the 1 gigabyte plus to 600 megabytes on JVM, and then to 200 megabytes when it was compiled for native. And of course, the reason is that we can package on native. We can package the application on. Well, it doesn't even have to have Java in the container, so the container image is actually very light. Then there's the tan column sort of in between. So that's the memory. That's the memory requirements. So it used to be that the application took about 1 gigabyte to run. Well, with JVM Quarkus, it was about 230 megabytes, and with native, it was about 41 megabytes. So that's pretty good. That's in fact that's about 20-to-1 ratio of memory requirements going down. And finally, there's the brown column, and that's CPU usage. So from 350 millicores under maximum load, it went down to 150 for JVM Quarkus. So that's more than 50% reduction. And finally, on JVM, there's on native there was 170 millicores. So that goes up. I mean, the more you restrict the memory, the more it's going to require CPU. So there's actually a time-space trade-off there. But it's pretty good. And well, this was resource utilization, and then there's of course the performance side of things, right? So there's the startup time, which went down from about 1 minute to about 6 seconds on JVM Quarkus, and then to about 0.2 seconds currently, I think, for native Quarkus. So it scales quite a bit faster as well, actually. And then there's the throughput thing. So on Thorntail, we had a throughput of 3.3 calls per second. And that went up to 4.7 on JVM Quarkus and 4.2 on native Quarkus. So yeah, we did see some pretty big effects migrating on Quarkus.
Yeah, really nice to see the numbers.
Yeah, and mind you, this is not like some example applications. Because usually when you see these presentations, these are from applications that are built for demoing, right? This I measured from one of the microservices we've had in production for 1.5 years, like I said. So this is real numbers.
Yeah. Nice. What about porting to Quarkus? Was it a tough challenge or
well, I mean, yeah. Well, the thing is that the thing about that is that I would say if you have like a modern application that you've recently built, it's fairly straightforward to migrate it onto Quarkus. I mean, without going too much into the details, the issue with Quarkus migration is that if you want to do native, then you have to know exactly what's in the application to be able to migrate it. Like, I mean, long story short, you have to know exactly what it does to migrate it. And the issue with legacy applications is, of course, that we don't know what those applications do, right? We don't actually know all of it. So that's why you're probably going to want to have your greenfield applications on Quarkus and maybe migrate something that's fairly recent.
Yeah.
Otherwise, it's going to be a pain.
Mm-hmm. Okay. Thank you for this, Eero. You can send out questions in the chat to all of us if you have any questions. See if there are any questions in the audience.
Everyone is muted by default, so the chat is the best chance.
Yeah. Yeah. So basically I don't see any questions coming in, so I think we can close the session. I want to thank all the presenters for joining, and if you have any questions you can contact us at Opin Kerfi, and we can mitigate the responses back to our colleagues if you have specific questions to them. I just want to thank everybody for joining in, and please don't hesitate to contact us, and for any questions or if you are considering trying out these OpenShift as a platform, please don't hesitate to be in touch. Okay, thank you everybody, and have a nice day.